All right, so let's talk now. Let's talk. Because I'm done rotating 90, 180, 270. Too easy for us now, right? So right off the bat, I'm asking, hey, let's start at point E, and let's rotate 72 degrees. Where do I end up? How in the world are we going to measure 72 and I'm not giving out protractors? Luckily for us, this is not just a pentagon, it's a regular pentagon. Anybody remember regular polygons? What do I know about regular polygons? Griff?
All sides are congruent.
And all the angles are congruent. So here's what I'm trying to tell you. The fact that this is regular tells me when I rotate from point E to point P, it's the same amount of degrees as if I rotated from point P to point A and so on. You guys think you can find out how many degrees that is? Is there a way? Well, let me keep going. Let's say I go all the way back to point E. How many total degrees have I gone? From E to E. I went all the way around. Thank you. 360. I went 360 degrees. Agreed? How many turns did it take me to get all the way back? Sorry, maybe you didn't see that. Okay, maybe one more. Brendan, maybe they didn't pick up my. Here you go. Ready? How many turns? 5 turns. Every turn's the same amount of degrees, and I went 360. How can I find how many degrees are in each turn now? Grab my calculator. 360 divided by 5 equal turns. Oh, what nice number comes out here. 72 degrees. Look at that, kids. So every time I rotate vertex to vertex, I'm going 72 degrees. Makes this question very easy now, doesn't it? So if I start at point E and rotate 72 degrees, and I should have said this at the beginning, this is positive 72, so clockwise or counterclockwise? Counterclockwise, that's the way my arrows are going now. So if I start at point E and go 72 degrees, what vertex do I end up at here? 8, what vertex do I end up at? Point P. Yep. So it's not that bad, even if it's not 90, 180, 270. All right, let me try to up the level here. Now I want to rotate 216, but I'm going from point X now. I'm sorry, point P. Point P. It's around X. So if I start at point P and I go 216 degrees. Well, you only gave me 72. All right, watch. Here we go. Use your calculator. From P to A is 72. From A to T is 72. So how many degrees have I already gone from P to T? 144. And now I go another 72. How many total degrees have I gone? 216. So if I start at P, go 216 degrees, what vertex do I end up at now? 19? Point N. All right? So don't let it scare you that I'm not going 90, 180, 270. It's probably going to have some type of relationship to the figure you're rotating around. So there's a pentagon. What's up, Paul?
Does about X just mean you're rotating it like around?
Around X, correct. Because take a look. This is 72, that's 72, that's 72. So yes, I'm rotating around X. Yep. Good question. Anything else? All right, well, there's a pentagon. Sorry. Let's do it for an octagon. 8's up. Pretty clever, huh? Oh, octagon has 8 sides. That's why it was clever. Well, I don't go 72 degrees anymore. I'm not going 72. Can you help me figure out how many degrees I go from vertex to vertex? Well, again, it's always 360 all the way around, but now, how many turns is it going to take to get back to my original vertex? Whether you start at G, I, E, doesn't matter. How many turns now? 8 turns, right? So 360 divided by 8. Now when I go vertice to vertice, it'll be how many degrees? Not 72, but 45 degrees. Yep, vertice to vertice is 45. So let's do the first one together, and then you guys have 2 through 6 in your group. So rotate a rotation of G, point G, 45 degrees. Point G, 45 degrees. Where do we end up? 4. Where do we end up? Point I. Good work. And then you guys go right ahead. 2 through 6. Do not get scared when you have to rotate a segment. Rotating a segment is the same as just rotating the 2 points. All right, go ahead, talk it through in your group, by yourself, whatever you prefer. And I'll call on 1, 2, 3, 4, 5 people here in a minute. What do you say? All right, question 2, 225 degrees. 7, where do I end up? Do I have a 7?
Oh, wait, sorry.
Hi.
What was the question I was on?
I'm math. How are you? Question 2, 225 degree rotation. Where do I end up?
Point I.
Aye, good save. What's up next? Ooh, 315. 21? Aye. Unfortunately, that's it for the eyes. All right, now I'm going to rotate EI. It's the same as rotating E and I. Going 270 now. What segment do I end up with? 13? GH, HG, however you wrote it. And then how about point S going 135 now? Point S, 135. 2. G, point G. I don't know why I put a segment there. Oh, and then I saved the tough one for last, huh? 360 degree rotation. Even though I know some of you did 45 plus 45 plus 45 plus 45 till you got the 360. 21, where do I end up? ST, back at the beginning, right? All good? All right, here we go. Everyone like my equilateral triangle? I'm going to rotate it clockwise. Here's what I want to know. What's the minimum number of degrees it's got to be rotated to carry it onto itself? Now, you guys see I have that boxed in. What do I mean by carry it onto itself? Everyone see the equilateral triangle you have on your paper and I have up on the screen. How many degrees do I need to rotate it so I see a triangle that looks exactly like that? Easy answer would be 360, right? But there's less degrees you can rotate it. All right, so carry it onto itself, you get an equilateral triangle back. I want the same looking figure back. Yes, you are correct. 360 is an answer, but it's not the minimum answer. So get an equilateral triangle back. Minimum amount of degrees. You're right, it would take me 360, but it's even less. Even less than that. Ooh, what do we think here? What do we think? And think about what we've been doing with the octagon and the Pentagon. It's the same thinking. If I take this top vertice and rotate it to where this vertice is, I'm going to get this triangle back. So how many degrees is it going to take me to do that? What are our thoughts here? Want to share some thoughts? No thoughts? Jonathan, hello.
Because there's 3 vertices, you could divide 360 by 3.
I can, yep. So how many minimum amount, Jonathan? 120. You know what else? It would also take me I could do it in 240, and then I could do it in 360 to get back to the beginning. But minimum, 120. Good work, everyone. Good work. All right, so you guys seem okay rotating points. Can I rotate a full line on a graph? Can I rotate a full line on a graph? Ooh, this is going to get good now. I want to take this line right here, 2x plus y equals 1, and I want to rotate it 90 degrees. I want to rotate it 90 degrees. What's the equation of the new line? Can we see what this bad boy looks like first? 2x plus y equals 1. You probably don't like the way that looks. Why not? You probably like it when it's Y equals maybe? Y equals, you like that graph better? So do I. I like it a lot better. So can you help me get it Y equals so I can graph it quickly? What do I do with the 2x? Subtract it over. Yep. Y equals negative 2x plus 1. You guys help me graph that? What's the y-intercept? 1. So I graph 1 on the y-axis. How can you use the slope to get me a couple more points? First, what is the slope? Negative 2. So where can I go from this y-intercept?
Down to.
Down to? Right 1. Yep. Down 2, right 1. And then you can just freehand it, grab your calculator, side of your calculator, whatever floats your boat. But here's the equation, or here's the line. And I want to rotate it 90 degrees, and what's the equation of the new line? So let's do what we did yesterday right now. Let's do what we did yesterday so you can get a visual of what I'm looking for, because I can't do it up on the screen, all right? I can't take this bad boy and start rotating it myself. Everyone take your paper right now. Take your paper. It is positive 90, so clockwise or counterclockwise? Counter. Everyone ready? One turn to the left. One turn to the left. Look at that line you have in front of you now. I want to know what the equation of that line is. All right, and again, the 2's, the negative 2's, the positive 2's, they don't matter now because you have a new XY axis. I want to know, what is the equation of this line that's staring you right in the face now? All right, well, let's talk. If I'm going to need the equation, it's got to be in y equals mx plus b form, right? Look at your paper. If it's still turned, keep it turned, please. Can you guys help me with the slope of this line? Slope of this line that's right in front of you right now, turn 90 degrees. Pick 2 points that you definitely know. What's the rise and the run? Anybody? What's the rise and the run of this one that's on your paper right now? Up and over how many? Up 1 over 2. Everyone agrees? But tell me something about that up 1 over 2. I don't feel comfortable. Actually, I do feel comfortable doing that. Never mind. 1/2. Hey, honors kids. Anybody know how else I could have gotten 1/2 without even looking at my paper?
Negative. No, not negative.
Yeah, Paul. Yeah! I know, you're right.
Oh, yeah.
You're right. How many degrees are we rotating this? So they're going to be what to each other? Perpendicular. What do you know about the slopes, Paul? They should be -2, positive 1/2. Good work. Good work. You surprised yourself there, didn't you? Yeah, everyone's like, whoa, way to go, Paul. Right? Good job. All right, so yeah, I could have, I'm rotating into 90. They have to be negative reciprocals. What's the only piece I'm missing now for this line? I got the slope. I'm still missing the... Okay, and I'll tell you what. I know some of us could probably look at this line and be like, you know what? I think it's 1/2, but you don't want to rely on that. Might be a third, might be a fourth. You don't want to rely on the graph here, especially if I didn't use a straight edge. So how else could I find the y-intercept? Plug in a point into y equals mx plus b. Anybody got a point they're confident in? Looking at your paper right now? Got one, Tammy, that you're confident in?
Yeah, -1, 0.
-1, 0. Everyone confident in that point? Yeah, it looks like to be on there. All right. So if I'm going to use -1, 0, what do I plug in for the y coordinate? What's going in for y? 0. We already figured out the slope was 1/2. Your x coordinate? -1 plus b. And now solve for b. And yeah, we would have been right if we guessed, but still not confident the way that graph looked. So 0 equals -1/2 plus b. Add the 1/2 over, and yes, our y-intercept is positive 1/2. So somebody right now, can you finish this for me? What's the equation of my rotated line? 9. What's the equation of my rotated line? Y equals There you go. 1/2 x plus 1/2. Good work. Questions on how we got there? So kind of like yesterday, we literally just rotated our paper and said, all right, here's the slope, rise over run. We weren't really confident in the y-intercept, but we found it algebraically. All right, I'm going to let you guys read through this next one and try to figure it out on your own. And then we'll talk. Number 9. So what do we think here? We're gonna do a line reflection, and then we're gonna do a translation. Am I changing the size of it? Is the triangle changing size when I reflect it and translate it? No. So at least they're going to be congruent because I'm not changing the size or shape. And will they be similar? Are congruent triangles similar? Yep, same size, same shape. So we got choice 1 here. Congruent and similar. Everyone all right? You're not changing the size and shape when you translate and reflect. 10 on your own too, or in your group, you can talk about it before we get to the big one together. This one's a good one. Take a triangle, rotate, reflect it, and then rotate it 180. And it's a hexagon. Get ready. Ready? Starting triangle is ABG. You're going to reflect it over BG. Where's it go? Name the triangle. Where's it go? If I take ABG, reflect it over BG. Not my final answer. I just want to know where this one goes. 3. Where's this triangle go, Eva? BGC. So now I'm at BGC. And I want to take BGC and rotate it 180. 180. And remember, it's a hexagon, so I did the work here beforehand. Every vertex is 60 degrees. What triangle do I end up at? 17. Where do I end up? Right here. Yep. Good work. I end up at this triangle right here, FEG. Any issues on that? Got to explain that anymore? Last one. This one's a tough one. This one's a tough one. Ready to go. So I have rectangle ABCD. I have 4 transformations listed. Which one will not carry the rectangle onto itself? Meaning, which one's going to move this rectangle? I'm not going to see this rectangle in this exact spot again. One of these is going to move it. All right, I'm not going to see this rectangle in this spot right here. So let's go through each one right now. How about a reflection in the line y equals x? Great review here. Great review. Can anybody tell me what point A is here? What's point A? What are the numbers on A? 7, 1. All right, let's review. I gave you guys a rule for when you reflect over this line y equals x. Anybody remember the rule? We're going to know it by Friday. Paul?
You just flip them.
Swap them. Yep, swap them. So now it becomes, guys, take a look where 1,7 is for me. Where's 1,7 on this?
Point D.
Nothing moved. Right? Nothing moved. Let's try it one more time. What's point B? Somebody give me coordinates of point B. 9, 3. So if I did it reflected over the line y equals x, it would become swap them. 3, 9. Where's 3, 9? Point 6. Do you see this rectangle's not changing? It's staying the exact. The vertices are changing, but everyone's seeing it's staying right where it is. It's not moving. Agreed. Okay, so that carries it onto itself. It doesn't move it. Ooh, this looks like the answer because it just looks intimidating. Negative x plus 10. What's that line look like? I want to get a visual of what that line looks like. We just finished graphing a line. Here you go. What's the y-intercept? Y-intercept?
10.
Okay, go up to 10. I think there's 10 spots here. Here's 10. What's the slope of this line? Negative 1. So I can go, ready? Down 1 over 1. Down 1 over 1. Down 1 over 1. So I want to reflect it through this line right here. Where's A going to go if I reflect it over that line? Pretend you're folding it over. It's going to go to B. Where's C going to go? Am I going to get a new rectangle out of this? Nope. So this carries it onto itself. Son of a gun. All right, so it's got to be one of these rotations now. Oh, sorry. So let's what about a rotation of 180 around 0.66? Find 66 for me. Find 66. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And a reminder, what's 180? A rotational 180? Is it a rotational 180? This is 90, just directly on the opposite side. That's what it is, right? So if I rotate 180, point B rotated 180 around this point, what's on the other side already? C, and C would go to B. What's the problem, though? Yeah, that's great, but what's going to be the problem?
A doesn't go to D.
A, on the other side of this point, where's it going to be? Is it going to be on D? It's going to be somewhere up here, isn't it? Right? Because it's got to be on the other side of the point I rotate around. Agreed? And then point D will be somewhere over here. I'm going to get a different rectangle. All right? C and B will stay in the same spots, but everyone understand why D and A are going to move now. 180, opposite side of the point. So that's it. That is my answer, but I also want to go over why number 4 would work, because 4 is also a rotational 180, but what's the difference? Look where 5, 5 is. 1, 2, 3, 4, 5. 1, 2, 3, 4. Where's A going to go? Rotate it 180 around that point. Where's it going to go? Where's it going to go? Where's A going to go when I rotate 180 around this point here? C. Where's B going to go? Okay, that's why it stays the same, but it won't stay the same for 6, 6. All good? Questions, comments? All right, well, since there is no assignment tonight, a reminder that don't do that assignment on the bottom. That's what we're doing in class. I think we have another vote out coming up here. This is for quiz number 2 of Unit 8, the SOHCAHTOA quiz.